So, hi everybody. We are here at the EPFL Swiss Federal Institute of Technology in Lausanne. And in the background you see the famous stairs which inspired Martin Odersky for the Scala logo. So the Scala Center is here and we've just been visiting the Swiss Center for Data Science. And in front of me that's François from Skymind. He is a deep learning engineer at Skymind and I just want to ask him some questions. So welcome François. Thanks for inviting me. Actually he was the guy who invited me to come here. So what's your role at Skymind?
So at Skymind, I work on both developing our open source libraries for deep learning, including DeepLearning4J, an ETL library called DataVec, and a library doing very fast array manipulations on your GPU called ND4J. And then I worked on a commercial product for Skymind called Skill that deals with the life cycle of your model, model serving, and how to deal with having a deep learning model in your organization that actually is part of your organization, part of a pipeline that serves data and advanced analytics to your whole organization.
Okay, very nice. And what is the main difference of DeepLearning4J if you compare it to TensorFlow and Theano and MXNet and all those libraries?
Oh yeah, so the first difference is in the name. So DeepLearning4J is a library that does deep learning for Java. But the nice thing behind that is that it can actually leverage the Java ecosystem and the JVM ecosystem, leveraging things from Apache Spark for distribution that we integrate with as a first-class citizen, to the Scala language if you're interested more into interoperability, and into notebooks, interactive manipulation of your data, to a lot of other components of that wonderful ecosystem that has generally been geared towards distributed. And that's really nice because the neural network these days are getting a bit more mature, and distributed is the way to go for large-scale training. But we also like that and appreciate the fact that most data scientists like to work with Python, so that we have focused on Keras as a layer that lets us talk to the Python world. We are very happy to do Keras model import today, to be a backend for Keras in the near future, and to deal with the memory representation of, say, NumPy arrays, to ingest your data from the Python world and let you integrate with that nice JVM world without necessarily having to know anything about it as a data scientist. So we're really careful about the roles. We love working with data scientists that are really data scientists and that are focused on the modeling. And we like to give all the tools for data engineers that are also focused on making that run efficiently and that are really interested in the performance of modeling and then model serving and integrating that into an enterprise. And we try to bridge those worlds. So in a way, we're translators between various different systems, and our Swiss Army knife to do that is the JVM.
Okay, so that means actually I can start using Keras, and I can start using Keras with TensorFlow, with Theano, and in the near future also with DeepLearning4J. Can you say something about your implementation of the binding between NumPy arrays and the ND4J arrays?
Oh yeah, so you can, so to the first point, you can definitely use Keras, and Keras is that wonderful library that is a high-level library that doesn't make you feel stupid when you want to learn how to do modelized deep learning, to use deep learning and to modelize a neural network. Now, it has a very nice API that has backends, and in its former version, those backends including Theano and TensorFlow, and we're going to release very quickly a backend for DeepLearning4J as well, so that you'll be able to develop interactively using Keras, but then run using DeepLearning4J on your individual machine or pro machines. And then we're also conscious that you have data that you need to manipulate, and that the memory representation of that data is really important. And the backbone of all our libraries is ND4J, that very efficient array manipulation library that lets you perform computation really quickly on your GPU. And there is such a backbone in the Python world already called NumPy. So we have created a one-to-one memory mapping between our arrays and NumPy, and we're able to execute our operations very quickly on your data without necessarily needing to transform it, misrepresent it, translate it into any other format. That's a big advantage in terms of performance and simplicity as well. And it's a big advantage over other frameworks, even in the Python world, like TensorFlow, that have a separate array format. So we call that encoding of our operations, but on NumPy memory representations using Java. We called it, of course, we had to call it JumpPy.
Okay, very nice. And one question on that. So are you actually copying data from the Python process to the JVM? Just the format is the same, or are you somehow accessing directly the memory from the Python process?
Yeah, so it's a memory mapping. So the idea is that you really have your data represented or saved as a NumPy array in memory. And perhaps you have a Python process that is already trying to talk to the data, but we just consider your NumPy memory representation as something that we can access directly, like many things do in the Python ecosystem. There's a lot of accelerated things that have been done with Jython or Cython that deal with NumPy arrays at the low level without necessarily going to another process. So basically, when you give us your model and you give us the data that comes with it, right? You will give us the Keras model defined using Python, and that's fine, we understand that, but you will also give us your data, and your data is probably going to be represented using NumPy, what you're used to in the Python world. And we want to access that directly without firing any kind of Python process, without having to do any kind of translation. So you give us the memory address in which your NumPy array is, we dereference that memory address, and we read the data directly from memory without the need for any kind of Python process.
Oh, that's awesome. Then the other thing I've noticed is you just can switch on GPUs very easily on ND4J. So can you tell me what are the steps for doing so?
So ND4J, contrarily to what a lot of people think, is actually a fully accelerated GPU library. So it's not the JVM that is trying to have a special communication process. We use the JNI, the Java native interface, to talk to exactly the same accelerated libraries as everybody else, and those are low-level C++ libraries that are dealing with that are communicating with your GPU. But to do that in a formalized, principled manner in Java, you need an API, and ND4J is that API. And it has two backends. It has a native backend and a GPU backend, and the native backend will execute on your CPU. We actually release and optimize that backend using the usual libraries that you're probably a fan of if you do scientific computing. You can have that use BLAS, you can have that use MKL if you have a license for that, and run it really fast on your CPU, and then at the flick of a switch, it's literally a one-line change in your build file. You can use that on your GPU and use low-level libraries like CUDNN that will execute your array operations really fast on the backend and the hardware that you have, because you want to use that hardware. The nice thing is that we pre-choose all the C++ libraries and we embed them for you. So you don't have to try to figure out the low-level C++ stuff. You don't have to figure out which one is the more optimal. We have worked on that on our own. We expose that at the level of an API. You just have to tell us, hey, do you want to use CPU or GPU? And you're already using accelerated low-level code as is in your Java array manipulation library.
Awesome. And if you now want to parallelize on Apache Spark, I've learned that's also as easy as turning on GPUs. Is that correct?
Yeah, so it's also a one-line change in your model, in your build for ETL, for example. So we have a library called DataVeg that does a heavy use of Spark as a first-class citizen, and it can really help you to have a distributed Spark cluster to bring a lot of data from various places in your organization into one format that is very precise and pre-processed to optimize your neural network training. Then in the neural network training, you can use Spark. We have multi-layer model training inside of Spark as a native first-class citizen that you can use in Java or in Scala. We will offer, we have that for you in open source, and then we will offer something a bit more advanced, a bit more performance very quickly in the open source release. But at the moment, all I can say is have a look at the open source pull request on the DeepLearning4J project. It's going to be really interesting. And then we'll make a little bit more noise about it when we're ready to do so.
Okay, so basically what you are telling is you are accelerating the traditional parameter averaging training master and come up with something better. Is that correct?
Yeah, we have something better in preparation, but I'd rather make sure that we have that polished and finished before I talk too much about how much better precisely it is. But yes, we already have an existing way of distributing your neural network training. It works reliably, and it's something you can use from day one as part of the open source library without any particular configuration. And you can do that in a demo in Scala on a notebook, and I know a few people that have been very successful doing so, among which you.
Thanks a lot. Another thing is, do you support all the well-known types of neural network layers like convolutional and LSTMs and so on, autoencoders?
Yeah, so we have added variational autoencoders very recently. We, of course, support convolutional layers. We support RNNs. We support LSTMs. And all of those major types are present and accounted for. Now, of course, we try to follow the state of the art as close as possible, but naturally, we're an open source project, and if there is something out there that isn't in here, that isn't in DeepLearning4J, we are eager to help people integrate that as quickly as possible, because it's to everybody's advantage to have a library that is fully featured and complete that supports absolutely everything.
Okay, I have to say they have a jitter channel, DeepLearning4J, and those guys never sleep. And if you ask a question there, they are so helpful. That's the way I met this guy. And maybe last question, how do I get started with DeepLearning4J very easily?
So that's actually part of the answer. We have that jitter channel, which for us is the way to interact with people that are starting to get into DeepLearning4J. So we're an open source project that includes a documentation, and there's a number of tools and tutorials out there. We have a YouTube channel that integrates lessons on how to start with DeepLearning4J, for example. But if any of that is insufficient, and it probably becomes insufficient at some point if you have questions, we have a jitter channel. We have people from both the open source community or Skymind that are in that jitter channel and really active and really reactive. There is that culture of communication. We don't want to leave you out there with your questions. We really want to help you out. So come on the jitter channel. We will make the investments to help you with your questions, because we've seen it pay off in the end. Usually, if you like that library, if you like working with us, you're gonna be successful, and then you're probably going to give back to the community in the true open source way of things.
Yeah, exactly. That's what I'm doing. I was contacting you in the jitter channel, and now I'm giving back new examples written in Scala. So yeah, thanks a lot, and have a nice day.
Thank you, and thanks for your contributions.
Thank you. Bye. Awesome. Thanks so much.
No problem.